Hello everyone, welcome in my virtual math class. This class is for class 10 of West Bengal Board, and today's topic is theorems related to tangents of a circle. In previous class, we already discussed a theorem of this chapter. The statement of the theorem was the radius and tangent are perpendicular at the point of contact. The radius and tangent of a circle are perpendicular at the point of contact. Now we will do two theorems. Today we will do two theorems of this chapter. Now statement of the theorem is theorem 41. If two tangents are drawn to a circle from a point outside it, then the line segments joining the point of contact and the exterior point are equal and they subtend equal angles at the center. This theorem is very important in exam purpose. Again, I read the statement. If two tangents are drawn to a circle from a point outside it, an external point of a circle, maximum two tangents are drawn. At external point, maximum two tangents are drawn. Then the line segment joining the point of contact and exterior point are equal. So that is the length of two tangents. The length of two tangents are equal and they subtend equal angles at the center. Now, at first, we draw the figure of this theorem. Now, we draw a circle. This is the center. Now, this is an external point. This is center O. Now, we draw two tangents from an external point. Here P is an external point. AP and BP are two tangents through an external point P, and A and B are the point of contact, and the equal angle at the required to prove length of two tangents, that is AP and BP are equal and they equal angles at the center. At first we write given. This is now given. P is an external point. P is an external point of a circle with center O. AP and BP are two tangents through the point P. Required to prove RTP in short form. Required to prove length of two tangents. Number one, AP, the line segment joining the point of contact and exterior point. So AP is a line segment and BP is another line segment. Number 1, AP equals to BP. And number 2, they subtend equal angles at the center. This tangent subtend the angle AOP at the center. So measurement of angle AOP is equals to measurement of angle BOP. Required to prove number 1, AP equals to BP, and number 2, AOP equals to BOP. Proof of the theorem. No construction. Now we compare in two triangles. In triangles OAP and triangle OBP, we have number one angle OAP is equals to angle OBP equals to one right angle because OA is a radius and AP is a tangent. In previous theorem, radius and tangent are perpendicular. So OA and AP are perpendicular. So this angle must be right angle. Similarly, OB is a radius and BP is a tangent. So radius and tangent are perpendicular. So this is also 90 degree. Right? OA is perpendicular to AP and OB is perpendicular to BP. So that triangle must be right angle triangle. In right angle triangle, the opposite sides to the right angle is the hypotenuse. So in the right angle triangle, this angle is 90 degree. So therefore, triangle OAP is a right angle triangle and triangle OBP is also a right angle triangle, and this angle is 90 degree and this angle is 90 degree. So therefore OA is the opposite side to the right angle. So therefore OP is the opposite sides to the right angle. So therefore OP is the hypotenuse of the right angle triangle OAP, and also OP is the hypotenuse of the right angle triangle OBP. So OP is the common sides. So hypotenuse OP equals to hypotenuse OP. Common sides. And number 3, OA side OA equals to side OB. From triangle OAP, OA is a one side and OB is another side. Two sides are equal because radii of a same circle, are equal. OA is a radius, O is a center, and A is a point on the circumference. So OA is a radius and O is the center and B is the another point on circumference. So therefore the line segment OB is the radius. So OA and OB both are radii of the same circle. So therefore OA equals to OB. So in two triangles, one angle is right angle. Length of the hypotenuse are equal and length of each sides are equal. So therefore triangle OAP is congruent with triangle OBP by RHS right angle hypotenuse sides, RHS criteria for RHS congruent criteria for congruency by RHS. And we know if two triangles are congruent, then the corresponding sides and corresponding angles all are equal. So two triangles are congruent. So therefore, now corresponding sides. This side equal to this side, and this is the common side. So therefore, the remaining sides AP and remaining side BP are the corresponding sides. So therefore, AP equals to BP by corresponding sides of congruent triangle, CSCT. In exam you write full form. Corresponding sides of congruent triangle are equal. AP equals to BP and AP equals to BP. AP and BP are corresponding sides, so their opposite angles are corresponding angles, and the opposite angle of these sides, angle AOP. Angle AOP is equals to angle BOP. Corresponding angles of congruent triangle are equal. Corresponding sides of congruent triangle are equal. Now prove the theorem. AP equals to BP and angle AOP equals to angle BOP. Prove. And so many students write OA equals to OP, both are radii of the same circle, and OP is a common side, and angle OAP equals to angle OBP because they are 90 degree. Right, OA equals to OB, OP is common side, and angle OAP equals to angle OBP because both are 90 degree. Both are 90 degree. Then two triangles are congruent. No, this is wrong. When two sides, so this is from AS, angle must be included angle. So here this angle is not included angle. So the two triangles are congruent by RHS congruency, not SAS congruency. Anybody write SAS congruency, get no credit. Okay, copy the theorem. Next theorem, theorem 42. Now statement of the theorem 42 is, if two circles touch each other, maybe externally, maybe internally, if two circles touch each other, then this point touch each other, the touching point, then the is called point of contact. If two circles touch each other, then the point of contact will lie on the line segment joining the two centers. The statement of the theorem is, the point of contact is lie a line segment is the point of contact will lie on a line segment joining two centers. Now we draw the figure. Now we draw two figures. One figure is two circles touch each other internally. This circle is centered at O and this circle, small circle, is centered at B, touch each other internally at the point B. The big circle is centered at O and the small circle is centered at B. Two circles touch each other internally at the point P, and another circle, this circle is center at O and this circle center at D. These two circles touch externally at the point P. In the both cases, P is the point of contact, and given two circles center at centers at A and B touch each other at the point P, maybe externally or internally. So we draw two figures, touch each other, maybe externally touch, maybe internally touch. So two circles center at A and B touch each other at the point P. Required to prove centers at A and B, required to prove the point P, the point P lie on A, the point P lie on A line AB. The point P lie on a line AB joining two centers. Now construction. Line A and B are joined, not AP and BP are joined. Now we join AP and BP. Now we join AP and BP. We join AP and BP. Here we join AP and BP. And also we draw a tangent at the point P. We draw a tangent at the point P. We draw a tangent at the point P. This is the tangent. Now tangent at this point. This is the point P. And now this is the tangent line. And the tangent is RS. Tangent is RS. Construction. The construction is AP, BP are join, and we also draw a tangent. Also we draw a tangent RS at P. Proof. Now A is the center and P is a point on circumference, so AP is a radius in both cases. AP is a radius and RS is a tangent. Now AP is a radius and RS is a tangent. Therefore, AP is perpendicular to RS. Using theorem 40, radius and tangent are perpendicular. Also, from the small circle, B is the center and P is a point on circumference, so BP is a radius. Also, BP is a radius and RS is a tangent. Therefore, BP is perpendicular to RS. Now, AP is perpendicular to RS and BP is perpendicular to RS. Two lines are perpendicular at the same point P. If BP is a radius and RS is a tangent, so BP is perpendicular to RS at the point P, right, at the point P, and AP is perpendicular to RS at the point P. AP is perpendicular to RS at the point P and BP is perpendicular at the point P, same point. So therefore AP and BP, therefore A, P, B are collinear. A, P, B are collinear. Therefore, the point P lie on the line segment AB. Proof. This is the proof. AP and RS is perpendicular at the point P and BP and RS is perpendicular at the point P. Two line segments is perpendicular at the same point. So therefore APB are collinear. Prove the theorem. Now copy the theorem. Next we go to the exercise of this chapter. Let us see by calculating 15.2. Number 1. An external point is situated at a distance of 17 cm from the center of a circle having 16 cm diameter. The distance of external point from the center is 7 cm and diameter is 16 cm. So therefore radius must be 8 cm. Let us determine the length of the tangent drawn to the circle from the external point. What is the length of the tangent through an external point? At first we draw the figure. Now we draw a circle with center O and radius equal to, diameter is 16 cm, so radius is 16 by 2 cm. This is equals to 8 cm. And P is an external point whose distance from the center is 17 cm. Here P is a point and distance of OP, and OP equals to is given 17 cm. Now OP equals to 17 cm. Now calculate the length of the tangent through the external point P. Now this is a tangent, AP is a tangent through an external point P. What is the length of AP? Now we join A and O. So OA is a radius and AP is a tangent. Join O and O. So therefore OA is a radius and AP is a tangent. So therefore OA is perpendicular to AP and therefore the triangle OAP triangle OAP is right angle triangle. Right angle triangle. So this is the right angle and OP is the hypotenuse. From Pythagoras theorem, OP square equals to OA square plus AP square, which implies AP square equals to OP square minus OA square, which implies AP equals to square root, not taking plus minus. Here AP is the length and length always positive quantity. So AP equals to plus square root of OP square is 17 square minus OA square. OA is radius. Radius is 8 centimeter. 8 square. Now 17 square is 289 minus 64. Now subtract 5 2 2 and square root of 225 is 15. So therefore length of the tangent is 15 centimeter. This is the answer. Copy it. Next, number 2. The tangents drawn at the points P and Q to a circle intersect at A. The tangents drawn at the points P and Q to a circle intersect at O. If the angle PAQ equals to 60 degree, PAQ equal to 60 degree, let us find the value of angle APQ. At first, we draw the figure. Now we draw a circle whose center at O. Two tangents at P and Q. This is the point P. This is the point P and this is the point Q. Intersect at A. This is the point A and this point is P and this point is Q and center is O. Given angle PAQ, this angle is 60 degree. Measurement of this angle is 60 degree. Let us find the value of angle APQ. APQ. This is the angle APQ. What is the value of angle APQ? APQ is unknown. Now AP and AQ are two tangents through and common point A. Now AP and AQ are two tangents through an external point. A is an external point. Through an external point A. So therefore, from theorem 41, length of two tangents AP and AQ are equal. So therefore, AP equals to AQ. Now, in triangle APQ, AP equals to AQ. In a triangle, the length of two sides are equal. So therefore, the triangle is an isosceles triangle. Isosceles triangle. In isosceles triangle, the opposite angle to the equal sides are equal. So therefore, angle APQ equals to angle AQP. APQ equals to angle AQP. So therefore, but one angle is 60 degree. So therefore, sum of other two angles, angle APQ plus angle AQP is equals to sum of three angles in a triangle is 180 degree. 180 degree minus 60 degree. This is equals to 120 degree. But both angles are equal. So therefore, each angle, angle APQ equals to angle AQP equals to 60 degree. Sum is 120 and both are equal. So therefore, each angle is 60 degree. So therefore, angle APQ equals to 60 degree. Copy it. Okay. Thank you. Next, sums. Sums number 3 and 4 are homework. Okay. Thank you.